All right, let's take a look at finding all roots of a polynomial equation. We're going to do four examples here. It says state the degree of the polynomial, find all real and imaginary roots of the equation, and state the multiplicity when it is greater than 1. So let's take a look at, first of all, finding the degree of the polynomial. Well, this first one is quite clear. When there are no parentheses, then it's basically in standard form and for a polynomial, and we want to make sure that the exponents are decreasing. Okay, that's the order that we want it to see it, and that the exponents are decreasing in number. So I have 5, 4, 3. That means that this right here is my leading term, and the leading term is going to always tell me my degree. Okay, so this is a 5th degree polynomial. 5th degree. Okay, it's to the 5th degree. Now it says to find all real and imaginary roots. Well, we know that a root is basically at the x-intercept of the related function. In other words, if I put a y back in here and graphed it, we're talking about the x-intercepts. And so basically what we've done is we've taken out the y and replaced it with a 0, and that always means we're looking for x-intercepts. So those are what we're talking about when we talk about roots. So the first thing I want to try to do, you might think, well, should I do the PQ thing, Ms. Savelle? Well, you notice that there is not a constant here at the end. There's no constant at the end, and so I really can't do the PQ method of finding all the roots. So what I'm going to try is I'm going to try factoring it. And I notice that all 3 of the terms have an x cubed in them, so I'm going to factor out my x cubed. Well, that factored pretty nicely. So now this x cubed factored out, so it's a factor, but this trinomial is also a factor. And so I want to continue to try to factor the remaining factor. So here's what we have so far. All right, now none of these can be factored anymore, and so now we're going to be able to just set each of the factors equal to 0. So there's that one, there's that one, and there's that one. Now if I take the cube root of this x cubed, then what I've really found is I've found that x is 0, x is 0, and x is 0. In other words, I have x sitting there 3 times because it's x to the 3rd power. And so in essence, I have x is 0 3 times. We don't usually write the repeated roots. What we write is, we call it a multiplicity. We say multiplicity 3. So this x equals 0 has multiplicity 3. So we'll go ahead and solve these others. We have another 0 of 1. Excuse me, of negative 1, pardon me, of negative 1. And there's another one of negative 1. So I have a root of negative 1, multiplicity 2. All right, so there's that first one. Now, by the way, let's take a look at our all of our roots. We should end up with 5. The reason is it is a 5th degree polynomial. All right, we have 0 showing up 3 times. We have negative 1 showing up twice, in theory, basically. Okay, let's take a look at the next one. Now, this is not a 3rd degree polynomial because it has parentheses, and I can't really tell the full weight of the polynomial, so to speak, unless I can imagine the parentheses gone, or if I wanted to actually multiply everything together, I could actually make the parentheses completely disappear. But let's just look at what it means. Maybe you can picture the degree more easily. This does mean x plus 1 to the third power, meaning writing it 3 times. Okay, so there we have it. We have the whole thing written out. If I multiplied all of this together, I would have an x to the fourth at the beginning of the polynomial, and then I don't really care what would be following that, because that means that this is a fourth degree polynomial. In other words, when the parentheses are gone, we can tell what the degree is. All right, so now there's a fourth degree polynomial sitting there. What I'm going to do is I'm going to set every factor equal to 0. Now I know that this is not necessary, but I'm just writing it out for you. So we basically have this. We have x is -1 with a multiplicity, I'm going to just abbreviate, 3, right? X is -1, multiplicity 3, and x is 3. Now notice the direction said, state the multiplicity when it's greater than 1. Okay, so this one here has, it's not a multiplicity greater than 1. X is, the 0 is at 3 only one time. Okay, let's take a look at another one. All right, so now on this one, I do have a constant at the end, so I could do the p's and q's thing to figure out all the possible roots, and then I would use the synthetic to figure out which ones possibly worked. It would be all the possible rational roots. But I'm going to actually look a little closer and realize that this thing can actually be factored as well. So factoring is always obviously the best way to go instead of the PQ thing, right? The rational root theorem. So it looks like it's going to be -9 and -9. So, oh, by the way, this is a second degree, right? Second degree polynomial. Because of this right here, that means that there are a maximum of 2 roots. So you can tell just by looking at it, we don't even need to do the steps of setting each of those factors equal to 0. But x is 9, that's a 0 with a multiplicity of 2, because it's sitting there 2 times. All right, let's finish up with one last one. And here we go. This one, again, doesn't have a constant at the end, so I'm actually not able to do the PQ method of looking for possible rational roots. So I do notice, though, that there's an x to the fourth power in common. And so I'm going to take out the x to the fourth, and I'm left with x squared plus 1. So I have x to the fourth is equal to 0, and I have x is therefore 0, and that's going to be a multiplicity, obviously, of 4. When I set this other one equal to 0, I have x squared. Be careful about this one because it can be deceiving. I'm going to go -1 minus 1. This is x squared is equal to -1, and we know that when we take the square root of both sides, we get, we get x is plus or minus, right? This right here is the square root of, the square root of -1 is I, right? Plus or minus. And so we get plus or minus I, 1I. And so there are my other 2 roots, right? We knew, well, let me just write it. We knew that this was a sixth degree polynomial, which means it has to have 6 real and or imaginary roots total, right? So we have it right here. We have a multiplicity 4, so 0 is a root 4 times, and then we have our other 2 are right here, plus or minus I. Okay, so there's an example of a couple of imaginary roots. Here are 4 real roots, but we still get 6 roots in all. So let me go ahead and put this over here. X is 0 with a multiplicity of 4, and x is plus or minus I, and obviously that's the other 2. Okie doke, hope this was helpful. Thanks for watching.